8th grade. We have a test this week, and of course we need to study. So this is our review video. This video is going to cover sections 2.2 to 2.4. Even though I have 2.1 here, we already have a video on that, so I suggest you look at that for a little bit of help. Hoping everything's all right, let's get started with some practice. In section 2.2, we were introduced to the concept of one-step equations, equations that can be solved with simply one step. Keep in mind, anytime we're doing an equation or we're solving an equation, we are trying to isolate a specific variable, and I'd like you to keep that in mind as we progress through. Even though this is one step, do go through the examples and make sure it makes sense to you, because we're going to build on this knowledge in the next section. If these problems look easy to you and straightforward, that's great. Go through the examples with us. Make sure that what you know is really on point, and feel comfortable to fast forward if you want to into the next section 2.3. If these problems look kind of scary and a little bit difficult, please pay close attention and let's do the best that we can together. I'm going to try to do our answers or do some work over here in yellow. Looking at number 1, I feel almost mad to say that this is one step, because technically I think you can call this a two-step equation. But the one step is so minor that we're going to talk about that I'll still include it as a one-step equation. I'm going to take 18, I'm going to rewrite this minus a negative s as a plus f, and then that's equal to 91. Now I feel better to say it's a one-step equation. I need to get rid of the 18 because I'm isolating my f. To get rid of this 18, I look at how it's related to f. It's just being attached by addition. When it's being attached by addition or subtraction to the variable that we want to isolate, what we do is we do the opposite. So I'm going to subtract 18 from both sides, or basically I'm adding a negative 18 to both sides. That cancels out, and I'm left with f is equal to 73. Don't be afraid when you see this equation. This is a lot like the first one that we had. Really, we're going to isolate w. We want to get rid of the thing that's being attached to w. And because the 2/5 is being attached to w by addition, we are going to subtract or add its opposite on both sides to get rid of it. And we do that by doing simply this. Adding a negative 2/5 to both sides. These guys cancel out. We're left with a w on this side. On this side, we're left with a minor problem, 3/4 minus 2 over 5. We need to come up with a common denominator, and if you think a little bit, you'll realize the common denominator is 20. Because 4 can go into 20 as 5 can. When I rewrite this fraction, 3/4 now becomes 15 over 20, and 2/5 now becomes 8 over 20. This makes subtraction far easier. 15 minus 8 gives us 7, and so we're left with 7/20. This next example has x as our variable, the thing we want to isolate, and 5 is attached to x by multiplication. 5 is the coefficient of x, and we need to get rid of it. In order to get rid of 5, we've got to do the opposite, which is division. So I'm going to divide both sides by 5. A little bit of style here. I'm seeing a lot of people, when you guys do this, you're showing me a little division sign when you're dividing both sides by 5. It's a little cumbersome. The preferred method is to use a fraction bar for that division. So I'm going to ask you to kind of transition to that mode. Anyway, back to the math. So we've got 5x over 5. Those guys cancel out. I'm left with x is equal to 1/5. The key to these types of problems is to always remember to get rid of the coefficient of x, even if the coefficient of x seems like it's smaller. All right. Last thing I said didn't exactly make sense to me, so I want to really clarify, and I'm going to put this thought in pink. It has nothing to do specifically with the examples here, and I want you to at least think about what I was trying to say. So here it is. Sometimes when students see stuff like this, 8x is equal to 2, there's a knee-jerk reaction to say that, oh, x must equal 4, because the student sometimes forgets to divide both sides by the coefficient and divides both sides by what I'm going to say is the convenient looking number. In this case, this would be incorrect, and I think you guys recognize that. What you need to do is divide both sides by the coefficient of x, which in this case is 8, even if 8 is larger than the number, or the coefficient is larger than the number that you're going to divide into across the equal sign. So in this case, x is equal to 1/4. All right, thanks for that trip into my mind. Let's continue with our examples. Finally, in example number 4, we have our variable c that we like to isolate. The only number on this side of the equation is 4. And what is 4 doing to c? It is dividing c. The opposite of division is multiplication, so we're going to multiply both sides of the equation by 4. As you can see, good things happen when you choose to multiply both sides by 4. We get rid of the 4 in the denominator, and c is isolated, which is what we want. It's by itself. I'm left with 9/8 times, and I can write this as a fraction, 4/1. What I'll do is I will cross cancel. This is totally legal when you're multiplying fractions and very helpful. 8 divided by 4 is 2. 4 divided by 4 is 1. And now I can write this. C is equal to, don't forget your negative, negative 9/2. To practice problems like this, please turn to page 140 in your text, and there are a set of problems under the heading Section 2.2. In this next section, Section 2.3, we're going to be solving multi-step equations. What I'd like you to really focus on is the fact that these equations really have the same steps as the last one. Well, the same idea as the last one. We're going to isolate the variable. This time it might take a couple more steps. Pay attention to the order of the steps and how we process through them. And the next thing I want to remind you is that there's going to be more examples than just these 3. So if you're writing your notes down, make sure you save space for at least 2 more examples. When solving equations like this, I really like to think about not just isolating the x or isolating whatever the variable is. The first thing I like to do is isolate the term. So everything that's being multiplied or divided into the variable, I like to isolate that first. To do that, I need to get rid of my 27. You guys know from previous examples, we're going to add the opposite, add negative 27 to both sides of the equation. We get 99, negative 99 on this side of the equation. These guys cancel out. I'm left with 9x is equal to negative 99. Finally, I need to isolate x. Who's bothering x? 9 is. Get rid of 9. How to do it? 9 is multiplying. Let's get rid of it by dividing. What I do to one side, I do to the other. And you see, I get that x is equal to negative 11. In this equation, we have 1 plus r over 9 is equal to 4. We want to isolate 4, but we want to isolate r, but before we can isolate r, we need to isolate this whole term, r divided by 9. So what I'm going to do is get rid of my 1 by adding a negative 1 to both sides of the equation. When I do that, my 1's cancel out. I'm left with r over 9 is equal to 3. Finally, I need to get rid of this 9. It's bothering r. How is it bothering r? By division, and I undo that by multiplying. What I do to one side, I do to the other. The 9's cancel out, and r is equal to 27. In example 3, our goal is to isolate our variable z, but it's a little tricky how to do this at this time, because z is attached to 6 by addition, but then kind of attached to negative 2 by division, and what to do? What I want you to keep in mind, when you have a situation like this, in a sense, there's a parentheses, let's say, around 6 plus z, because this negative 2 is going to be dividing into 6 and into z. There are a number of ways to approach a problem like this, but here's my suggested method. Get rid of the negative 2 first. Because of this kind of parentheses that exist around the 6 and the z, you want to get rid of the 6 last. So in a way, 6 is closest to z at this particular time, and we're going to get rid of the negative 2 first and the 6 last. So to get rid of a negative 2 that is dividing into the variable or dividing into this whole side of the equation, what we will do is we'll multiply. What I do to one side, I'm going to do to the other. So I'm going to multiply this side by 2. That looks terribly messy, so I think that's a little bit better. And so what we see is on the left side of the equation, we'll get 28. And on the right side, we are going to cancel out our 2's. Probably would have been better if I'd used a negative, but we'll get there. So what happens is I'm left with a negative 6 plus z. And to be quite honest, I don't like how that worked out. I should have multiplied both sides by a -2. I'm going to do this one over. I think it's just more convenient to rewrite it this way. We could have done it with the +2, but then we would have had this floating -1 and some people would have felt uncomfortable. Let's go. So we multiply both sides by -2. The -2's cancel. So I canceled out conveniently this denominator, so life will be good. And I get a -28 on my left side, and on the right side of my equation, I'm left with 6 plus z. This equation is pretty straightforward in terms of solving. I need to isolate my z. I'm going to add the opposite to both sides, and I see that z is equal to -34. So in this example, I want you to consider, let's call the number n. If the first number is n, the next number would be n plus 1. Let's actually write n there. Okay, n plus 1. The next number is going to be n plus 2. And the final number would be n plus 3. So if you look at these numbers, when I add them up, they should give me 54. Now what we need to do is join like terms on the left side of this equation. So I see that I've got not 1, not 2, not 3, but 4 n's. So if I add up all 4 of these n's, I get 4n. Then I've got these other terms, 1, 2, 3. I'm going to add those guys up, and 1 plus 2 plus 3 is 6. So 4n plus 6 is equal to 54. This looks just like any other equation that we've been working on this multi-step section. So I'm going to isolate n by first isolating the n term, getting rid of the 6 by adding a -6 to both sides. What that yields is 4n is equal to positive 48. And if that's the case, then n must equal 12. I kind of skipped a step there. Let me take that out and do better, be a better teacher. So here's our 8. Divide both sides by 4, because still I'm in the business of isolating n. How is 4 attached to n? By multiplication. So we divide both sides to do the opposite. And then we see that n is equal to 12. Okay, there are several other examples of the consecutive number situation. I encourage you to take a look at your textbook. Sometimes we have not just consecutive numbers, but consecutive odd and consecutive even numbers. When you have that situation, you're going to start off with n, but your next number will be n plus 2, and the next number after that will be n plus 4, and the next one n plus 6, etc. I only have a few more minutes before I have to publish this because I only get 15 minutes per video, but I really want you guys to take a look at this next example, and I couldn't help but add it to this particular section. What we need to do is isolate a, but the problem here is we've got these denominators. Fractions often terrify people. I want to show you a method that is kind of like absorbing the denominator by multiplying by the least common multiple on each side. If you look at 5, 9, and 15, the number that the least common multiple is 45. 5 goes into 45 evenly, 9 does, and so does 15. I'm going to multiply both sides of the equation by 45. I got to use a little distributive property here, and I'm going to multiply this by 45. Check it out. Well, it was a little irritating. Hopefully this is not so bad. 45 times 1/5 times this -1/5 is really 45 divided by 5. So that's going to end up with a -9 for us. Over here, we're going to multiply 45 times 4/9. 9 goes into 45 5 times. 5 times 4 is 20, so this becomes a -20a. On this side, 15 goes into 45 3 times, and we're left with 3 times 2, which is 6. This is a much simpler equation, and all of you can solve it. When we isolate the -20a term, this is what we get. Then we're going to isolate a by simply dividing both sides by the coefficient. When we do that, we get that a is equal to -3, that's after reducing, over 4. Okay, page 141 has great examples of this entire section, and be sure to do problems under section 2-3.